Welcome to this session. In this video, we will learn second chapter of class 11 physics, that is units and measurement. So in our previous discussion, in previous video, we discussed and learned about introduction of physics, where we learn history, brief history of physics and mathematics tools which we need to know in understanding physics or learning physics. So in this chapter we will mainly discuss and learn about units and measurement and the dimension of physical quantities. Okay, so this after having learned tools which we need in physics, mathematic tools which we need in physics, the next important part to understand physics is units and its measurement of physical quantity. Okay, so here let's see. First, we will try to discuss some important terms, and then we will move into this units and measurement. Okay, so other part we'll see a little later. So as I said, important terms. So first of all, we must know very basic terms here, that is to know units and this measurement. First we must know the term called physical quantity. Okay, so some terms, as I said, those terms are physical quantity or quantities, then we have unit, and then measurement, and later part of this chapter we will see dimension as well, dimension of physical quantity. So the most important thing here is physical quantity. Why? Because as we know, physics is all about nature and natural phenomenon or phenomena. So this natural phenomena, nature, we call physical quantity. We need physical quantity, we see physical quantity there. So that's why to actually to understand physics, one must have idea of physical quantity. Okay? So first let's begin here, the physical quantity. So let me write here some important terms, some important terms. There are so many important terms we have, but right now to understand this particular chapter, so I will introduce these three terms first. Number one, physical quantity or quantities. Then number two, of course, the unit or units. And number three is measurement. So these terms actually are not new at all to you. Why? Because this physical quantity, unit, measurement, somewhere in lower class you studied about this thing. So as we know, this 11 class 11 is the base foundation class. So here we must know all the basic things first. So that's why we start from the basic thing, and slowly we will move on to the deeper part of physics in higher class and even in this class. Okay, so this let's try to understand this particular thing, physical quantity, right? So when we talk about physical quantity, so physical quantity, many physical quantities are there. When we see, we find mass, length, time, many are there. Okay, acceleration, term like density, volume, area, so many this type of terms which we use in our daily life or in day-to-day life, those terms are called physical quantity. Okay, so let me write here the definition. Physical quantity, physical quantity, physical quantity. So how do we define? These are the quantities in terms of which, okay, these are the quantities in terms of which laws of physics can be described or explained, and we must know the measurement of those things, quantities, is very necessary here. Okay, so this is how we define. It's very, in a simple way we can define. So it may be defined as, we can, let me write the definition: all the quantities in terms of which, okay, laws, principles, theories, laws of physics are described, okay, or explained, or understood, whatever. And we must write here, and whose means whose here stands for this quantities, okay, physical quantity, whose measurement is necessary. It's very necessary. We must know, or we must able to measure it, necessary, are called physical quantities. So in a simple way we can try to define it. Okay, so this is how we define physical quantity or quantities. Okay, quantities, let me write here. So this is the thing, this is how we define. Okay, let's see example quickly. So already I told you the examples, like the terms like mass, length, time, okay, and velocity, area, density, many more, etc. We call this as physical quantity. So this is just introduction. We'll see again classification of physical quantity a little later. So this is the definition and the quick example of physical quantity, because I want you to make familiar with these three terms first, and then we will go to this chapter gradually. Okay, now let's go for this unit. Let's define this unit. Okay, unit or units. What is unit or units? So again, this is not new term for you, because you have done this thing in lower class, somewhere in class 9. So let us try to understand this term again. Let's try to redefine or relearn this one, rediscover this term. So in physics, when we talk about unit is something, we can say, a reference standard, okay, chosen, or a reference standard which randomly taken, okay, randomly chosen, or a standard reference standard. It's a standard, okay, of same kind. We will see this thing. So let me define first, and then we'll discuss about this. So we define the unit may be defined as the arbitrarily chosen or reference standard. See, this is very important. It's a standard, reference standard. We refer this thing. We'll see. We refer this thing to do some other thing. Okay, so this we will see then later. The arbitrarily chosen, or this is or reference standard of same kind. This is very important. Same kind. Okay, reference standard of same kind. This is very important here. Is known as unit. So, okay, this is how we try to define the term unit. So this is randomly chosen or reference standard of same kind. We'll see what is this. Let me explain this thing. Okay, so this definition may not be that clear to understand. So let me give this one example here. Let me take one very simple example. Suppose I want to measure the length of this page. Okay, I want to measure the length of this page. We know to measure the length of this page we need ruler or measuring tape. Any that length measuring that instrument will help you to get the length of this one. But let's not take those length measuring instrument here, device here. So let us think something else. Okay, something else, because in the beginning somebody they gave this reference standard as ruler or measuring tape. That's why we use those instrument device to measure the length of any object using those things, those instruments. But suppose if we suppose I want to measure the length of this one, and I want to measure this length using a reference standard as this pen. If I consider this pen as one reference standard to measure the length of this what called length of the paper, so what I will do, I will take the length of this pen. So what I am doing is, what I did is I considered this pen as one I took randomly. Okay, randomly I've taken this as one object which I will refer, which I will compare, which I will use to measure the length of this page. Okay, so this will be for me arbitrarily chosen or reference standard which I wrote here. Now there was one more thing of same kind. Now same kind here means since I want to find the length of this page, so I will take the length of this pen. Okay, so length of pen. So here the same kind is length here. Okay, the quantity here is length. So the physical quantity which I am using here is length. So if I consider this pen as my reference standard, then I can easily tell, see, if I measure it, I'll get hardly, I'll show you, 1, then I'll give another 2. So I'll get 2 times of this pen gives me the length of this page. So I can write here, example, to measure the length. Okay, just one example. Length of this page I considered pen. Okay, this pen I consider pen as reference standard, that is unit. I consider this pen as unit. So according to this consideration, what I can write, therefore length of the page or the paper is, just now we did 2 times, so I will write 2 pens. 2 pen. So I shouldn't write 2 pens, I must write 2 pen. 2 pen. Okay, so unit should not be written in that capital letter form, so that's why 2 pen. Now my reference standard is this pen, and this pen I measured, I compared 2 times. 2 times of this pen is equal to the length of this one. And this, why I took 2 times, because it's the 2 time length of this pen. Okay, so that's why this pen becomes my unit here. Okay, so this is how we do. So this is one just example. Let's try to understand a little later. So length of page here is 2 pen. So this pen I considered as reference standard, that is unit, 2 unit. Okay, now let me go for the next term, that is your measurement. Measurement, again we know measurement means nothing but is a comparison, comparison with a reference standard. So when we compare reference standard to any physical quantity or physical quantity with respect to this reference standard is known part, okay, and this physical quantity which we are going to measure is unknown part. Okay, so what we do here, we compare unknown to known component. So this is a comparison only. So we can divide, we may, oh, sorry, we can define, we may define measurement as comparison. Okay, so we can write here comparison of physical quantity. Okay, it's not that difficult. Comparison of physical quantity that is unknown, whose measurement is unknown with their corresponding reference standard, okay, that is unit. And always remember, these units are known. This is known unit is known as measurement. Okay, so this is how we define measurement. Okay, so it's comparison between physical quantity and the reference standard, that is a unit. The comparison between physical quantity and unit is called measurement. Simple. Now let's go for what called the explanation of this one. Let's describe this in detail. Let's learn it, this one. So let me write here explanation. Let me take the same example of the previous one, length of the page. So let me write here if pen is the reference standard, then length of this page will be 2 times of pen. So we shouldn't write pens, we write pen only. Unit we never write in plural. Okay, so this pen I considered reference standard, that is unit, so I should write, I'm considering pen as unit, so unit should not be written in plural form. So 2 pen, not 2 pens. Okay, so here this pen is the unit, like meter or centimeter, no? So that's the thing. Now if I go further, if you see this particular relation, here lies the measurement process, where we compare physical quantity with the reference standard unit. Physical quantity is length of the page and the unit reference standard is pen. So there is one I wrote 2 pen, means 2 times of pen. 2 is a pure number, numerical value, and this is the unit. Okay, now this gives one very important concept about the measurement and units, a measurement of physical quantity in terms of units. Okay, so here let me write, in general, we write in general, the length of page means this is a magnitude of physical quantity. Okay, this is called, let me write here, magnitude of a physical quantity. Now what is the physical quantity? There is a length of that page. Okay, and its magnitude we are writing. Magnitude, remember, magnitude means the positive value. Okay, magnitude of this physical quantity is equal to what we got here, 2 into pen. What is this 2? 2 is a pure number, so it's numerical value we write here, numerical value, right? Numerical value multiplied by the unit. Okay, that is the reference standard, so we call size of its unit. So this second part is unit. Done. So So this gives one very important relation, one very important concept about the measurement is that magnitude of any physical quantity is always expressed, always written in terms of numerical value followed by the unit. Okay, so the numerical value must be non-zero value there. Okay, now this can be converted into that formula form or in that symbolic form. Physical magnitude of physical quantity, let me use the symbol Q, is equal to this numerical value, let me use small n, and this unit as u, small u. So this is one symbolic representation where Q is our magnitude of physical quantity, n, that is numerical value, number, okay, and mostly the prime what called natural number, and then u is unit, reference standard. Okay, so this one. So here we find one sort of formula we can say. Now this can be further expanded for two system, more than two quantities, okay, more than two situation, two cases. So let me expand it. This can be written as Q. If I have, this is one way only, I use one physical quantity. If I go for more than one physical quantity, so I will get here N1 U1 equal to N2 U2. Okay, and this can be generalized. We can go for 3, 4, 5 and so on. Okay, so here we find this is always true. I'll explain this thing. This part I will explain, don't worry. Suppose if I take, suppose this explanation, suppose somebody measure the length of one plot of land. Okay, suppose I told 3 people, if I tell 3 people to measure the length of a plot of land, suppose this is the plot of land, okay, so if I tell 3 people to measure its length, okay, A, B, C, D, measure its length. So it is possible that first person length of plot of land, this is what we want to find out. Okay, so first person found length equal to 2 meter. Okay, second person found length as 200, 200 centimeter, and the third person found length as 2000 millimeter. Now what do you think here? Do you think they did wrong measurement? No, they did not. They measured all in a correct way, but they use different units. Okay, so meter one used, other one used centimeter and millimeter. So here we can say, therefore length of that plot of land is L equal to 2 meter, 200 centimeter and 2000 millimeter, right? So what does this 3 different relation tells us? That, see, this is unit, this is numerical value, again numerical value, unit, numerical value, unit. So this is nothing but same formula, Q equal to NU, numerical value into unit. and n1 u1 n2 u2, they are, as I wrote here, equal. This means this type only. See, this is n1, where this one is n1, this is u1, this is n2, this is u2, this n3, this is u3. Okay, so this is the same physical quantity is measured using different forms of that reference standard unit. So this is what I was what called q equal to n1 u1 equal to n2 u2. Okay, so here one very important thing we find here: meter, centimeter, millimeter. We know meter is the bigger unit than centimeter, and centimeter is bigger than millimeter. So this is bigger, smaller, smaller. So unit is in decreasing order. But if you see the numerical part 200 and 2000, so numerical value is increasing is found in increasing order. So numerical value is in increasing order and unit is in decreasing order. So what does it mean? It means that numerical value and unit of any physical quantity are inversely proportional. Okay, so here we can say unit, or let me write here, numerical values is inversely proportional to unit of that physical quantity. Okay, so this we should remember. So these are certain things which we must have with us, because this kind of thing you will find in entrance examination. Even in this multiple choice question, you may find this kind of question. So okay, so numerical value inversely unit, meaning numerical value increases, unit, the magnitude of unit will decrease, and vice versa. Okay, so this is about your physical quantity, unit, and measurement. Okay, now comes one very natural question, very common question. Why do we need measurement? What is the importance of measurement in our life or in real life situation? So because this chapter is all about unit and measurement, so unit we understood here, because this is a standard reference standard using which we can measure, we can find out the physical quantity. Okay, we can describe. So measurement, why do we need measurement? So this is very very common and natural question. So the answer is, we know, for accurate description of any physical phenomenon. Okay, so if you want to describe any physical phenomenon, you need measurement of quantity used in that physical phenomena, or that physical process. Whatever quantities are there, those quantities we must know. We must know its measurement. We must know the measure of those physical quantity. Then only you can explain the physical phenomena. So that's why measurement is important here. Okay, so let me write here as a note: for accurate description of any physical phenomenon, measurement of the quantities are essential or necessary. Okay, so this is the reason why do we need measurement of physical quantity. Okay, so these are the basics of your this chapter. This is the basic only. Okay, now we'll go in depth. Slowly we will go to depth of this one, right? So if we go further, when we talk about all these things, now there comes another question in front of us. Another question. Here we understand what is the need of measurement. Now next is, what is the need of standard unit, which we were talking about here, that reference standard. What do we need? Why do we need? So what is the need of standard unit? Why do we need? Okay, so for that, again, this question is very simple and very common and easy to answer. So some points are there, some requirements are there for this standard unit, and those requirements are very simple. Number one, everybody must have that standard unit must have suitable size. Okay, that must have suitable size. Suppose if I take number one. Number two, I can think about, we can tell accurately defined. That standard unit must be accurately defined. Okay, there should not be any confusion. Number 3 point, it should be internationally accepted. So that means everywhere that standard unit must be accepted. Okay, next point, it can be not it can be it must have easily available. Okay, that standard unit must be easily available. Next, we can say invariability with physical conditions. Invariability means which do not change. No? So standard units should not change with physical conditions like temperature, pressure, or with time. It should not change. Okay, so this type of these are certain point which are the requirements of a standard unit. So to make any standard unit, that standard unit must have this qualification. Okay, so this is very important question. You'll get question on this. So let me write this point here. Requirement of a standard unit. Okay, so what are the qualification of standard unit? So let me write point wise what I said just now. Number one, what I told a suitable size. It must have suitable size, not that big. We will see later on. Number two, it must be accurately defined. Okay, so accurately defined. So there should not be any confusion about the unit. So if we talk about the meter, see suitable size, we write meter. Size is very suitable. Accurately defined. Anyone can understand what one meter is. And number three, it should be internationally accepted. Okay, so it is not like that the unit somebody made and that unit is defined, confined to a particular area only. It should be internationally accepted. Everywhere in the world they must accept this unit. Okay, then we can think about it should be easily available. If we think more, it should be invariable. Invariability, so it should not change. Invariability with physical conditions. So what are the physical conditions? Physical conditions like temperature. It should not vary with temperature. It should not vary with pressure. It should not change with time. Okay, and etc. So these are the basic requirement or qualification of a standard unit. Okay, so this one must know this one. So we get question on this particular topic. Okay, so after this, now see, we are slowly moving into depth of this chapter. So basic things are over. Now, once we said all this requirement of standard unit, now next that obvious question is, who is responsible or who are responsible for checking all this thing? So there must be something, some body should be there, some organization must be there who can foresee all this kind of what call qualification requirements. Okay, so for that, of course, there is a body, internationally renowned body, and that body we call that organization we call general body or general organization or general conference on weights and measures. Okay, so this, its headquarter is in France, and in every country they have got their own weights and measure department. Okay, so they have their this particular organization or body. Okay, so let me write here, governing body, right? So this governing body is body we can say organization, okay, an institution, it can be anything. So we write here, we call them general conference or body organization on weights and measures. Okay, so this is the organization or the general body which checks the requirements of standard unit. Okay, so they are responsible for that. So they verify that particular unit, and then they announce this thing so that everybody should be accepted internationally. So its headquarter is in this house, headquarter is in France. Okay, so these are the certain you can say the extra knowledge we must have. Okay, so beside this, every country they have got their own weights and measure department, okay, to measure the standard of those what called physical quantity or units. Okay, so after this, so we understood those basic what call points on this chapter, and then we tried to define see the requirements standard unit and the organization who foresee all this kind of things. Right, now we shall go to the to detail or in that complete we can say depth of this particular chapter, units and measurement. Okay, so first let's quickly see the physical quantity. Already we defined, now we'll see the classification of physical quantity. Okay, so let me write here, classification of physical quantity. Classification of physical quantity. Right, so if we see if we talk about classification, there are two classes of physical quantity, two types of physical quantities. Physical quantity, they are which we call fundamental. Okay, fundamental, this is also called base physical quantity, which are distinct, which do not depend on each other or anybody else. And the second types of physical quantity we call derived physical quantity. Derived physical quantity. Okay, so these are the two classes of physical quantity. Again, when we go further, we'll find some more divisions there. Now these are the physical quantity, and if we talk about units, units also are of two type, we can say. Yeah, that is for physical quantity we find for fundamental physical quantity we find fundamental or base units. Okay, units, and accordingly here we find derived units. So according to your physical quantity, we have two types of physical quantity, broadly divided into two parts: fundamental base physical quantity or derived physical quantity. Accordingly, units, because units are for physical quantity, so that's why fundamental physical quantity, accordingly for this we have fundamental or base unit, and for derived physical quantity we have derived units, right? So this is the thing. This is the broadly if we talk, so this we find. Okay, now fundamental physical quantities are those physical quantity which do not depend on any other physical quantity, or they don't depend on each other, whereas derived physical quantity are those physical quantity which depend on fundamental physical quantity. Okay, so they depend on this. We'll see that example, don't worry, later on we'll see. If we talk about this, we have mass, these are the example, length, time. Okay, and many are there. Time, temperature is there, and so on. 7 are there, we will see later on, don't worry. These are the example of fundamental physical quantity. Derived, if we talk about its example, we have derived, we can say area, volume, velocity. Okay, then many, pressure, etc. So these are the example of derived physical quantity. When we talk about fundamental base unit, this part, these two things we will see little later. Okay, now this is not all about this thing. Now along with this fundamental and derived physical quantity, we have two more physical quantity, that is let me write here, somewhere here. Okay, this is called supplementary physical quantity. Supplementary physical quantity. See, this we don't keep among them. Okay, this is separate. So fundamental, derived, and this is separate. Now when we talk about supplementary physical quantity, examples are only two we use, that is plane angle and solid angle. This we will discuss, don't worry, we'll see later on. And accordingly they also have their what called units, so we call supplementary units for these two. Okay, so this is we just broadly we discussed about this one. Now if we go further, we will find some more here, we find here. Okay, so okay, now let me stop here. So this much for today, and in next video we shall see some more, the next point in this chapter, that is system of measurement. Okay, so what we learned today, we try to learn the basic terms used in this chapter, and the qualification of a standard unit, governing body, and the classification of physical quantity. Okay. Now after this, we shall go to system of measurement, which we will discuss in our next class. Okay. Thank you.